Well, welcome back to the Azure podcast. This is episode number 461, being recorded on the 23rd of May, 2023, with special guest Dave Salvator. I'm Sujit, and on Teams with me, we have, of course, our special guest Dave and Russell, and we're going to get to Dave in just a minute. But first, Russell, let's just cover some of the news. Uh, that you have today. And I know the build is probably going on as we speak here, so there's probably a lot to talk about, in the next few episodes of all the build updates. And we do have some special news today as well with Dave that would also be timed with the build with the Microsoft build. So, but let's cover some of the news that we have already. You had a couple in the hopper.
Yeah, just one that looks really interesting that caught my eye was around a new kind of storage, platform storage service called Azure Container Storage. So it's in preview now, and this is a kind of a very tightly coupled native storage platform service that you can use that works really closely with Kubernetes. So you can create these container storage pools that sit around your container clusters that can scale up and down seamlessly and integrate really well with Kubernetes. I think it's backed, by either Azure Elastic SAN, which is new, or Azure Disks on the back end. So you've still got all of the resilience and reliability and duplication that you'd expect from Azure Storage as well. But this is focused specifically at being a kind of a native to Kubernetes and Azure Container Services system. So great for those kind of persistent storage and persistent containerized applications that you need. So serving things like MySQL, Kafka, and Elasticsearch across your containerized application. So that looks really exciting. It's the first time I've seen it today, so I haven't delved into it a great deal, but it looks like something I'm going to have to get my head around and have a good play with later on.
Yeah, indeed, that sounds good. And also, similar to what you just described, also in the storage area, there is a new public preview for Azure Cold Storage now. So we used to have Azure, I guess, Hot and Archive, and now they have a kind of tier for storage that's sort of between Hot and Archive, right? So it's something that you would use not so frequently, right? At the same time, it's not like Archive where you kind of keep it for many years, and you probably never use it. This is for data that you would use less frequently. So obviously the pricing is better. So if you have information that you're going to, let's say, access over the next year or infrequently, then there's this new tier available to you called cold storage. Also, a couple of other updates. OpenTelemetry is a popular stack for logging in most applications these days, all logging metrics, etc. And now there is a distro that kind of blends the Azure Monitor cloud observability with OpenTelemetry, right? And you could use things like ASP.NET Core, JavaScript, Node.js, and Python now to emit OpenTelemetry traces and logs and metrics, etc., and have them captured by Azure Monitor, right? And then kind of sucked into Azure Monitor Lake. So it's all in one place for you, but your applications can use, like most of the applications you can find on GitHub these days automatically enable OpenTelemetry. And so this is a nice feature where they can be tied to Azure Monitor without much of a fuss. And then the final one I'll mention is the Azure Load Balancer. Now ICMP pings are actually inbound, are supported in Azure Load Balancer. It used to be that the pings were ignored, so you'd have to use something like PS ping to ping to probe a specific port, especially if you're troubleshooting access from the internet and you wanted to make sure that am I getting through to the inside VNet. You'd have to use things like PS ping and to probe specific ports. Now you could use ICMP ping. Just the normal ping to see, okay, is the load balancer alive? Is it responding? And not have to do something special. So those are some of the updates. I'm sure we'll have more as in the weeks to come. But for now, let's turn the mic over to our special guest, Dave. Dave, thanks so much for joining us today. Dave's with NVIDIA, and I'm going to let him introduce himself and tell us what he does at NVIDIA and what his passion is in the Azure space so that we can talk about that.
Sure. Good morning. It's great to be with you all. So as you mentioned, I'm Dave Salvator. I'm with NVIDIA. I'm a director of accelerated computing products. And what that means is I work with our cloud partners, Azure in particular, I do quite a bit of work with around enabling and helping sort of tell the story about some of the great technologies you were mentioning, and also talking quite a bit about a lot of the integration work that we've done together. In addition, of course, offering GPU instances, Azure and NVIDIA engineering teams work very closely to bring NVIDIA software into the Azure platform environment to make sure that Azure customers can get the most out of their GPU accelerated instances. And so that includes, you mentioned, for instance, Kubernetes is an area we've done work in together. A lot of integration into Azure ML, and we'll probably talk more about that today as we move through the discussion. And then just a whole wide variety of different enablings we do, both for instances as well as software integrations.
Yeah, so obviously this whole thing with AI in Azure has taken off in a big way recently, and I as a software engineer, want to wrap my head around that, see like what does it mean, right, for the next generation of applications. We want to build applications that can leverage some of the technology that NVIDIA and Azure is providing. What are some of the things that NVIDIA is looking to release, into Azure to help software engineers take advantage of this new paradigm of programming?
Sure. Well, one of the big ones that we're talking about here at Build is, of course, our NVIDIA AI Enterprise, which is our software layer of our overall NVIDIA AI platform, right? We're going to be integrating that, making it available in the Azure Marketplace, as well as integrating it into Azure ML. This will make it much easier for Azure customers to take advantage of these programs, which bring sort of enterprise grade, both support and software to the cloud for those customers who are looking to deploy sort of industrial strength applications and need to know that they basically have full-fledged support to be able to build those applications and basically troubleshoot them should trouble arise, and also just getting the most out of those applications to optimize both user experience as well as operational cost.
Now, prior to this announcement, right, what was the experience that what would application developers or enterprises have to do, right, if they wanted to use OpenAI or Azure ML features in Azure? Today, before this new announcement, what was the process for them to take advantage of these of the platform?
Sure. Well, so you can think of NVIDIA AI Enterprise as sort of taking what we call our NGC kind of to the next level. NGC is basically our container repository for all the great software that we make available to the community, right? That includes, of course, all the popular frameworks. It includes our own application frameworks for building sort of domain-specific applications. It also includes pre-trained models, test scripts, Helm charts. I mean, a whole variety of tools and resources that we make available to the community, which were available, I believe, previously through the marketplace, through what was called NGC. What NVIDIA AI Enterprise does is it takes all that and brings it sort of under one roof. In addition, it also then we've rolled out a very robust support platform so that Azure customers can basically get access to NVIDIA support as they're building their applications to ensure that they can get those applications built quickly and deployed so that those applications can start basically generating value for the teams and for the organizations building them.
So just so I can get my head around it, I've always kind of heard that, we've got GPUs available to do better AI processing, obviously running games, computing, and all that kind of stuff as well. In all of those instances, do I, as a software developer, need to understand what the NVIDIA SDK looks like and make calls specifically into those SDKs? Or is there a kind of a way I can build an application and say, I want to switch on some support and use the GPU for doing some of this stuff to make it run really quick?
So the answer is it depends, which is to say, it depends on sort of what level you want to engage, right? You can go all the way down and be writing basically bare metal CUDA code if you really want to. But if you want, there are plenty of other tools that allow you to engage at sort of a higher level with API calls that just make it easier to build applications, right? And in some cases, that's as simple as adding a few lines of code in something like, say, TensorFlow or PyTorch to actually turn on acceleration, and then use even some of our more optimized data formats. As an example, the default FP32 format in TensorFlow, I'll give you an example, uses something called TensorFloat 32 or TF32, which we introduced in our Ampere generation of products. It uses a couple less bits to describe the data, but for AI purposes, it's sufficient precision so that you get nice performance bounces without losing any accuracy, and it doesn't prevent any of your models from converging when you're trying to train them, right? So again, it's just a matter of kind of how you want to engage and how kind of deep down the rabbit hole you feel like you want to go.
Right. Oh, and when I want to do the same within Azure, if I'm in a VM, I guess it's just the same. I've got those options. If I'm not in a VM, what's the option there?
That is a great question. I believe, again, there's sort of the matter of there are these higher level tools that Azure makes available, including Azure ML, of course. And the ability to interact with those and then access NVIDIA sort of specific acceleration once you've got the VM instantiated should be available through relatively simple API calls from within the Azure ML environment.
Okay, thank you.
Dave, you mentioned Kubernetes and AKS. Obviously, that's AKS in the case of Azure. How's that integration done? Is it through like an extension, like an AKS extension or something, or is it just a matter of the containers that you load up in AKS now can take advantage of some of the repositories that you spoke of?
So in terms of how you can specifically be using AKS, we basically have support to automatically provision and manage and scale K8s, right, using our GPUs and our NGC containers, right? And that's kind of how we interact with the AKS service that Azure offers. So it's an ability to kind of scale up, scale down, use orchestration. And then as an example, our Triton inference serving software can also integrate into AKS so that once your application is deployed, you can leverage some of the features rather in Triton, which include things like auto scaling, as well as what we call auto batching, right? These are both really slick features in the server that allow you to, first of all, roll up and down compute as you need it. So when you think about the pay-as-you-go model, we all know that once an app is deployed, the demand pattern in terms of requests coming into that app can be spiky, right? You'll have times when it goes along at a fairly steady clip. And then at any given moment, you may have a transient. You may have a spike where suddenly you get a lot of demand, and you want to be able to meet that demand without compromising user experience, right? So that's where auto scaling can come into play. And then another one that's we may talk about this more in a few minutes as we talk about generative AI. When you think about real-time services, which a lot of AI applications these days are now needing to run in either real time or very close to real time. As you guys probably know, when you're working with AI, you typically talk about trading throughput for latency, right? As you walk up batch sizes, you typically get better throughput, and this is an inference centric comment. But as you do that, you pay for it in the form of higher latency, right? So what auto batching can do is it can basically, you give it a latency budget. Let's just say 500 milliseconds as an example. What it will do is it will walk the batch size up and down until it can dial in an optimal batch size within that latency budget. So if you think of 500 milliseconds as a sort of SLA, right? What you can do is make sure that you're getting the most throughput you can in those 500 milliseconds to get the most out of the compute that you're using while maintaining user experience and maintaining your SLA.
That is cool. And you mentioned, is it Trident? Is that the software that you call? Is that how you said it?
Yes, Triton Inference Server software. That's right.
And that's a separate software that NVIDIA will make available as part of this. How does that fit into the AKS deployment of your application, for example?
Well, we actually make it available today, right? It's available from NGC. And as we're announcing here at Build, it will now become available through NVIDIA AI Enterprise. And then again, it can integrate into AKS and then allow you to take your application and deploy it onto your VM using Triton. And then in addition to that, now get the support that we were describing a few minutes ago from NVIDIA to run that application to make sure that everything's running smoothly 24/7.
Okay, you mentioned generative AI, and that's the kind of topic that's on everyone's lips at the moment. I know I spend most of my time doing demos of Copilot and various other technologies like that at the moment. I talk about OpenAI. Were NVIDIA involved in any of that kind of that big model build stuff? I know there's a lot of processing involved in generating those large language models. And what's the story from NVIDIA's side?
Oh gosh, we've been so involved in large language models almost from the from the outset, right? I mean, if you sort of, get a little bit in the Wayback Machine for a moment and run the tape back a couple of years, what you'd see is what really sort of kicked off large language models to get us kind of where we are now is the transformer network architecture, right? Which was originally introduced by Google researchers a number of years ago. That's what ultimately powered BERT, which sort of in a lot of ways really took natural language processing to this whole other level. I mean, we've been talking about natural language understanding and processing for decades, and the sort of joke term for it, in fact, I think it was even Bill Gates who coined the term, was it is a computationally unbound problem, which is to say, it is just such a language is hard to understand, right? The words are relatively simple, but the context, the meaning, the social implications, there's all these subtleties to language that we have come so far in being able to bake into these models, which is, and now with things like, of course, ChatGPT and the great work being done by OpenAI, that, a lot of that work is happening on A100 GPUs, actually, has really brought the state of the art forward so far and relatively quickly, right? So we continue to do our own work. We have, for instance, what we call our NeMo language model. And we now have a service we're offering through that, which will be available also coming to Azure later this year. Will be sort of our NeMo framework for building large language model applications, right? And you can do any, a couple of different things with that. One of which is, of course, what's called fine tuning, where you can bring in your own data set and work with basically a pre-trained version of NeMo, apply your own data set to give it some domain specific knowledge of the area you're looking to build your large language model to serve, and then be able to deploy that quickly. And then, of course, you can sort of recycle and retrain on an as necessary basis to continue fine-tuning over time as your incoming data set, may change and evolve over time.
So you're kind of getting the conversational AI piece, the language understanding bit as your starter, then giving it a whole load of documentation or information to understand on the back of that and focusing it on that. So it's kind of like a private version of, I guess, a chatbot on steroids, I guess.
That can be certainly one application of it. Yes, it has the number of different applications for LLMs are wide ranging in many, right? I mean, and I think we're just beginning to see all the different places where they have a role to play. As an example, large language models in some cases can even go beyond language, right? Another one of the foundational model services we're going to be offering is called BioNeMo, which is actually using that same NeMo network, but with a very different set of data that's focused around accelerating drug discovery, right? So again, the applications for large language models, I mean, and you've probably seen as well, I believe it's called Copilot, which is now available on OpenAI, if memory serves, which can generate computer code, right? So, there's the number of things that LLMs can generate that's to me the really interesting thing is that it goes beyond just language, in air quotes, but rather it goes beyond it to look at things like generating computer code, being able to generate essentially genetic code, really, or in this case, basically molecules in the form of drug discovery.
Now, well, one of the problems that I've seen over and over again with GPUs, the NVIDIA GPUs, is essentially their availability, right? Oftentimes, and you talked about how you can auto scale and that go up and down, but if the availability is unknown, the auto scale may not actually work, right? We often find times where the nodes or the CPU GPUs are not available. So I was wondering, from an NVIDIA side, what is there something that's being done to kind of address that problem? How should customers plan for that, which is going to be something they're going to hit sooner or later, right?
Yeah, and I'm not working deeply in terms of working the supply chain side of things, but I can tell you we have a very strong supply chain. We've also recently, in fact, we just announced with Azure, it was a very exciting announcement at our recent GTC conference, that you guys have gone into private preview with your own H100 based instance, which is our current flagship architecture based on the Hopper architecture, right? And that's delivering anywhere from 3 to upwards of we've seen recently in MLPerf as much as almost 7x more performance versus when we first introduced A100. And so, we're bringing a lot more performance to bear in the form of H100. It's starting to deploy widely across CSP partners, including Azure, which we're, of course, very excited to see. And so we will continue to optimize our supply chain and keep our customers supplied with the GPUs that they need to build out the data centers they need to build. And that is something we're very focused on.
Now, we started talking about the generative AI and like what where do you see the future of AI and ML on Azure or on any cloud for that matter, right? Like what are some of the use cases? You mentioned a few use cases, but are there any future use cases that you see coming down? Like bio is one of them that you mentioned. What are some of the other scenarios where people can start using things like generative AI and ML?
Sure. I mean, well, I think we've only just begun to even really unpack all the places it can be used, right? I think what's been so exciting to see with generative AI, and Jensen has talked about this, generative AI in many ways turned everybody into a programmer, right? Because using prompts, and basically in plain language, you have the ability to describe the thing that you want, right? As opposed to having to learn how to write computer code. And then basically the application can take that, work with it, and then give you back, again, it can generate images, it can generate computer code, it can generate language, it can generate any number of things. In terms of places where this can be applied, I mean, just to name a few, certainly customer service. Russell mentioned, potentially chatbots on steroids as one potential use case. But as well, content creation, obviously, if you look at some of what's going on with text to image, and that's very quickly evolving towards text to video and even text to rendered 3D graphics, which of course kind of maps back to our original wheelhouse, which is where NVIDIA got its start, right? Of course, sales and marketing materials and generating content there, generating basically copy and summaries and descriptions, product design, education, fraud detection is another area where we see potential use cases. Healthcare, I touched on a few minutes ago as it relates to drug discovery and other types of medical imaging. Also, gaming, and then I also touched on software development. So I mean, those are just a few that I can think of off the top of my head, and there's probably a dozen more that we haven't even thought of yet. That's the other exciting thing when you put a technology like this out to the community, is what they come back and do with it that surprises you, right? Because there's sort of the ways we think it will succeed, and then there's sort of how it comes to the market and finds other ways to succeed beyond what we imagined.
Yeah, I think all these scenarios, you dream up a use case for how AI could help you solve something, and then for me as a kind of an ex-programmer now, I find it quite daunting. And what I am enjoying is things like Codex that you mentioned, GitHub Copilot comes along and helps you with that, because you can just say, right, I want to do something or other, and it as long as you explain it clearly and in enough detail, it figures out how to do it for you to some extent, and you figure the rest out. A lot of that now is getting easier because of the building blocks that companies like NVIDIA are putting in place. And, right. I'm seeing NVIDIA AI Enterprise as one of those. Are there kind of services out of the box that I can almost use directly, like facial recognition or text to speech, speech to text, all those kind of cognitive services that we have as well? Is there an NVIDIA flavor of those?
There is. It's an area of ongoing work for us, but we have what are called application frameworks, right? And they cover a lot of different areas. You mentioned as an example, computer vision. Deep Stream's a great example for that one, which can be used for a whole wide variety of applications, from smart cities to retail to any number of other applications where you need to be looking at a lot of video and doing video analytics and drawing insights from that. Is just one example. There are just so. Just one moment. I'm gonna quickly just pull up a resource so I don't forget a couple, because we have so many now. We have, again, for medical imaging, we talked about. This isn't the one. Okay, well, there are a number of for instance, there's Tokyo for building chatbots is one that I can think of off the top of my head. We have what's called Morpheus, which is around physics-informed neural networks, right? We have another one, actually, Morpheus is for security. I misspoke. But we have another one that is around physics-informed neural networks, which will come into play in places like Omniverse, like where you're looking to build what we call a digital twin, right? We have speech AI. We have also robotics, of course, with our Isaac application framework. So we have these different frameworks, many of which, we also have code samples. We have, again, pre-trained networks. We have the ability for you to basically just kind of do essentially, low code, not quite no code, but certainly, lower amount of code to get your application up and running more quickly and start, making sure that you'll be able to performance tune it and get it ready for deployment.
Now, Dave, kind of one last question I have is, this is all great, but we've all here heard about the security concerns around AI and ML, especially with generative AI. Customers are worried about their own information being used to further train the model, or
Sure.
or showing up somewhere else when it's not intended. So I was wondering, like, the enterprise software that you're releasing into Azure, does that touch upon any of these areas, to allay the customer's concerns here?
Sure. Well, I mean, a great example of that would be our service around what's called Picasso, right? Which is for text to image. It's sort of a business to business type play that we're doing. And it's a really interesting service because not only do we have access to beautiful content, that content has been properly licensed. And we've got signed agreements in place with Getty Images as well as Adobe to make sure that anything built using those bits of content as training material means that you as a customer can go ahead and build applications knowing that you have content that's been properly secured, properly attributed, such that you won't have any other sort of headaches once you get deployed. We've seen some stories in the news where certain types of content have been used for training, and the owners of that content coming back and go, that was done without my permission. And so there's still, I think, a lot of work to be done around figuring out for content owners, what's the right model for allowing some of their content to be used for training while making sure that they get, certainly attribution, and then also looking into some forms of compensation, right? I think there's some business models that can come out of that I think we have yet to really see fully take form. But ultimately, content licensing in some ways is actually not a particularly new business model. It's just now being applied to AI in the form of generative AI.
That's great. Thanks so much for that, Dave. Russell, is there any other question for Dave? Otherwise, we can wrap up over here today. It has been
No,
really
I don't
great.
think so. It just sets your mind off wondering about, there's a whole load of regulation around how AI should be used. So the regulatory services that dictate how companies can use AI and so on. But it's not that transparent, is it? Now we've got these large language models. There's so much complexity in there. How a company has used that to come to a decision that's doing something, affecting maybe your insurance premiums or whatever. It's just so complex. It's such an interesting area. And like you say, the thing about that piece about crediting people for their IP that's built into that training model and how that will happen. Yeah, it's mind blowing because I think I'm thinking about incremental payments, the like of Spotify, where you get a cent for a play somewhere or other or something like that. But it could become very complicated very, very quickly, and we're going to need some more AI just to deal with the logistics of how that's handled.
Yeah, well, it's interesting you mentioned that. There's in addition to kind of the attribution and the potential commercial side of it, there's also the matter of toxicity in content, right? Or content that is sort of within certain boundaries, right? And so as an example, we recently introduced something called NVIDIA Guardrails, which is actually an open source piece of software that we've put out there to help sort of guide some of the creation of content, to put in place some of those, again, as the name implies, guardrails to keep applications sort of within the realm of their intended use. In other words, that we'll try and keep toxic content sort of at bay, if you will, and keep you sort of within the domain that the application was intended to work. Right. And so that is something that we just kind of released it. We just put a blog out about it not too long ago. And we are now in the process of kind of rolling that out and look forward to seeing customers actually use that on Azure. It can be used on any cloud platform, of course, but we, of course, want to see them using it on Azure as just one more way to, again, build applications that are safe, usable, and deliver what we believe are kind of appropriate and hopefully sufficiently predictable results. As I mentioned, it is open source and it leverages other tools. There's a specific open source tool that it can take advantage of other toolkits. One in particular that we have looked at is what's called LangChain, for instance, which was recently very highly rated on GitHub. Right, that's just one of the ones that it can sort of link into, and it can link into others. And because, of course, it's open source, it can be modified on an as-needed basis. Right.
Yeah, that's great. I think the ethical and responsible use of AI is a really important thing to pursue. I think it's something we're always going to be catching up on because the technology, as far as enabling AI, is already out there, right? And it's growing faster than we can kind of think about ways in which people are potentially going to abuse it as well. So yeah, it's all great stuff though. So it's just gets your mind going.
Yes, it does.
Well, thanks so much, Dave. This has been fascinating. And please send us any of those links that and resources that you have mentioned. Some of the open source links. Please, give to us. We can put them along with the show notes with the recording. Right.
Yep, will do. It was great being with you guys.
Thank you, Samia.
Thanks very much, Dave.
All right, thank you.
Thank you all.